Hey guys, this is Ulrich from Nostalgic Mathematics. Today, we'll try to compute this limit. If you are new here, do not forget to subscribe. We consider the sequence an. At first glance, there is a striking term here, which is the square root of 4 minus an squared. So the key here might be the use of a trig substitution. Now, since 4 is 2 squared, we may just set up an to be 2 times the sine of tn, right? But we may have chosen 2 times cosine un by setting un to be pi over 2 minus tn. But in this case, I think the sign is more practical. Because of this outcome, do not forget, we want to compute the limit of 2 to the n an. So here we have a term before the sine tn. Like here, we have 1 over x before sine x. And you know that there is no similar result for the cosine because cosine x over x is going to negative infinity at the left of 0 and to infinity at the right of 0. So we don't have any similar result. So we're going to stick with the choice of sine here. Okay, so a0 rewrites as this. It is 2 times the square root of 2 over 2, which is 2 times the sine of pi over 4. So we may choose t0 to be pi over 4. Next, we will try to build a sequence Tn such that an is 2 times sine Tn and Tn is between 0 and pi over 2. I'm conscious that this assumption is not that clear at first glance, but this will get clearer as we move on. Now, if we replace an by 2 times sine Tn here, we have an plus 1 to be defined as follows. We can now factor with 4 here to have this. But since sine square plus cosine square is 1, this is going to be cosine square Tn as here. Now 4 cosine square Tn is 2 cosine Tn square. So we're going to have here 2 times the absolute value of cosine Tn. But since Tn is between 0 and pi over 2, now it is clear for you. Cosine Tn is positive, so we can get rid of the absolute value. As here, again, we factor to have 2 multiplied by 1 minus cosine Tn. That's where we're going to use our duplication formula. We know that cosine t is 1 minus 2 times sine squared t over 2. So we have this. So we're going to have here we're going to have 1 minus 1 plus 2 times sine squared Tn over 2. So 1 minus 1 is going to be 0. So we have 4 times sine squared Tn over 2. Again, this is 2 sine Tn over 2 squared. And then an plus 1 is 2 times the absolute value of sine Tn over 2. But the sign here is positive since Tn is between 0 and pi over 2. Tn over 2 will be less or equal to pi over 4 and greater to 0. So this is positive and we get rid of the absolute value. So to finish this kind of induction, we can choose Tn plus 1 to be Tn over 2. And we know that Tn plus 1 will be between 0 and pi over 4. But it is the same as saying that, so it implies that Tn plus 1 is between 0 and pi over 2. And that's good. We also see that Tn is a geometric sequence. So Tn is T0 over 2 to the power n. Very interesting. So our initial problem, when we consider 2 to the n an, it rewrites as this. So we're going to have 2 to the n plus 1 sine T0 over 2 to the n. Now we can rewrite as this. We just have 2 times T0 and 2 to the n over T0. We know that the multiplication of those two first terms is 2 to the n plus 1. And we keep this term. So it rewrites as this. We have this kind of expression, this pattern, sin x over x. So you see that it is now easy to compute the limit of 2 to the n an because T0 over 2 to the n is going to 0. So this limit is 2 times T0 multiplied by 1, the same one here. So it is 2 times T0. So the limit we were looking for is 2 times multiplied by pi over 4, which is pi over 2, and we are done. Thank you for your attention. Again, do not forget to subscribe, like, share, and put your comments. Bye.